Now, getting the right weather prediction can inform how you dress, how you commute, or what you grab off the supermarket shelf. Now, getting that wrong can end in a disastrous situation. Now, today, the gurus of weather prediction open the doors to us to show us that there is more to the Met Department than just giving us the daily weather forecast. Now, here we see how some of the best meteorological minds came together to demystify this logistical cobweb of the ever-changing climatic patterns and how that should concern you.
Weather and climate are the backbone of human survival. Dry seasons, mostly experienced in northern Kenya, force their residents to endure the scarcity of resources like water and food. Other areas like the Mount Kenya region enjoy fair, wet and cool seasons, allowing them the privilege of surplus food supplies, even creating markets for their produce. These varying conditions not only inform food security, but also transport systems and the quality of life. Kenyans living in these different regions are, however, able to navigate different weather patterns owing to the nation's advanced structures of climatology. The Kenya Meteorological Department, for the first time in its 50-year-old history, shows us how this institution crucially plays an important role in the planning and decision-making of the day-to-day lives of Kenyans.
People tend to ask us why it's flooding in a certain area. It's not our mandate, because for us is to give the expected outlook of projections of the weather forecast. Our information is reliable. I am talking about, from the feedback that we get, we are talking about accuracy levels of beyond 85, close to 90, and at times 100%.
It's 12:30, a few minutes before the next reading of weather data from these instruments based at the observatory station. Here, instruments are monitored to collect crucial weather data at regular intervals. Dorcas, a meteorological technologist, takes us through the different instruments and their functions.
Where we are here is the observatory, where we put our instruments. We call it the enclosure, where we enclose all our meteorological instruments. And next to us here is the sunshine recorder. And as you can see, we have there's a glass in this instrument, and this is very important because it converges the sun rays to burn this card. For us, this is our instrument that we use now to measure the sunshine hours. So when the sun is in the northern hemisphere, we use a different card. When it is the southern hemisphere, we use a different card. And when it is in the equator, we have a specific card for that. We have a specific a ruler that we use, a scale that we use to measure the sunshine hours. We are able to tell how many hours we had in a day. And this helps us to help the people that need to know, like the people who makes the sunshine, the solar panels and other stakeholders who want to know how many sunshine hours do we have in a day. As they design their solar panels, as even the farmers they prepare, they want to know, do we have enough sunshine? Do we have enough sunshine for our crops to grow? This is what we call the evaporation pan. And next to you, there is a wind anemometer. The two work together. They are put together near each other for a reason. So what we want to know here is after this water has evaporated, how far is it going? So if that moisture is carried a certain distance, the people who are now interpreting the data will know that at that particular point, the clouds may form there, and we are able to get, with other factors, we may be able to get rain or something, weather activities may happen there. So when you come in the morning at around 9 local time, but we say 06 UTC time, yes. So you come and check what has happened here. This is the level that we measure the water with. We call it the datum level. So when you come in the morning, if it has not rained the previous day, you add water to the pan. How many cups you have added to this pan until to the datum level, it's the amount of water that has evaporated the last 24 hours.
So after now the evaporation, How does that reading connect to the anemometer?
As you see under this anemometer, we have some readings here,
Alright.
and it is times 100 meters. So this shows it is measuring distance.
And now we are at the rain gauge.
Yeah, this is our rain gauge,
Okay.
ordinary rain gauge.
Okay.
So after the bottle is filled, the water goes here, and there's no event that will fill all of them, because rainfall measurements, we take them after every 6 hours. We don't wait for 24 hours or 12 hours. We take them after every 6 hours. So if it fills this one, it goes to this one, and before it fills, we have already taken the data. Yeah, so when you come in the morning, let's say it's 9, which we call it 06 UTC, you come and remove the way we have done it.
Okay.
You check whether there is water in this bottle. If there is water, you take a measuring cylinder. Yeah, if this was filled and there's more water here, you do the same. You measure all of it and then record in millimeters.
How does that translate to understanding the weather patterns or the rainfall patterns at that time?
If the rainfall is less than 5 millimeters, just for example, it's not so useful for the farmer. It may be just useful to make maybe the environment cooler, but it's not useful to the farmer. If in 24 hours we have gotten more than 25 millimeters of rainfall, that is an alert. That is much for them. So the soil will be so much saturated. Please wait for it to dry. Then now we continue with the activities. This is a soil tensiometer.
Okay.
It's used to measure soil moisture in the soil. So as you see, there are 3 following each other.
Right.
For different depths in the soil. So from the soil moisture, we come to the soil temperatures now. The same as soil moisture, we take the readings in different depths. We have 10, 30, and 100 over here.
All that data is recorded on these screens that digitally store live hourly data of weather patterns that are then stored in these servers alongside data from other 39 weather stations across the nation. Data from all these centers are collected at the weather headquarters in Nairobi and carefully stored in the servers under labels of flood-prone, drought-prone and rainfall-prone areas. After collection of data, the forecasting office helps in undertaking weather readings and produces forecasts that support the aviation, agriculture, education and marine sectors.
Before any pilot takes off, they have to be briefed on the prevailing weather conditions, the expected weather conditions en route, and in the alternate aerodromes, because that helps you in planning. So no pilot would dare take off without pre-flight briefing.
The data is integrated with the Global Telecommunications System (GTS) for global weather monitoring through the World Meteorological Organization (WMO), which acts as a designated center that provides specialized real-time weather forecasting, technical guidance and advisories, particularly for tropical cyclones and environmental emergencies.
When you come in as the duty forecaster, like one of the duty forecasters already explained to us, you have to look at the satellite image. So from the satellite image, what you want to look at is the current situation of the weather. And because weather has no boundaries, you cannot ignore what's going on with your neighbors. So we have to look at what's going on over the entire of Africa. And specifically right now, because we're in the season of March, April, May rains, we look at where the ITCZ is located. So from this particular run, which is valid for today at 12:50 UTC, which is local time plus 3 hours, that means 15:50 UTC.
The ITCZ, Intertropical Convergence Zone, is a translation of the mean sea level pressure MSLP to see the pressures within the African continent. Africa has 4 weather pressure cells that inform the weather conditions experienced in different regions.
4 main pressure cells that control weather over Africa, and one sits within the Mascarenes Islands over the southern areas of Africa, same to St. Helena, and then we have Azores region, and then the Arabian Ridge, which is an extension of the Siberian High. So the intensity, orientation, and position of this particular high pressure cells can act for us or against us. It just acts on the simple principle of physics where air moves from high pressure to low pressure. So if there's high pressure here, high pressure here, high pressure here, high pressure here, then it creates a form of like a compression box. So if you have force from here, force from here, force from here, and force from here, it will all be concentrated within the center. So our center in this case is the continent.
Through the Climate Prediction Center, weather conditions can be detected almost 2 weeks prior, but changes can happen when sudden weather disruptions like cyclones or intense weather conditions appear on the signal. That was a case in the recently experienced torrential rains in Kenya that saw severe flooding in Nairobi.
So what happened is that we had an early onset as compared to what we had forecasted, and for reasons that the pressures down south had intensified faster than normal, and that's why we had the onset earlier. But ideally what would happen is that if this was in phase, which means phase 2 or 3, then we have the ITCZ in play too, the rainfall becomes really intense. Maybe you would see for the first time in history, maybe 200 millimeters within a day. You never know, because the previous time when we had this impact, we had up to 70 millimeters within 24 hours for a station that had never recorded that much within 24 hours.
This is then what informs the issuing of an advisory using the Regional Specialized Meteorological Center that facilitates support for heavy rainfall.
First of all, as we look at different models, the different global models, to be able to come up with the consensus to give an advisory. You cannot just depend on one model. Like I mentioned, you have to come up with a consensus, because if all the models are communicating the same language, then this is it's more likely for that to happen than when it's just one model.
The Weather Research and Forecasting, WRF, runs daily and uses the same data in the GTS. It helps to flag out any probability of more than 50 millimeters of rain, since anything above 20 millimeters has seemed to be alarming based on recent advisories.
So if we see any of those signals, and then coupled with other models like the CPC that I showed you, and then we have the ECMWF, the European Center, and then we have something called the EFI, Extreme Forecast Index. This is specifically to flag out the anomalous rainfall. For example, if the rainfall will be more than 50 millimeters, it will give you the signal. So you're more confident when you're giving the advisory, because it will be a hit because of that. You have the index indicating between anything between 0.5 and 0.9 should be something that you should be worried about.
These predictions can, however, not always be accurate, since the simulation models can detect wrong probabilities that get affected by the sudden change in weather pattern.
There are times when we could go wrong, like in any other discipline, because forecasting is all about predicting how the weather will be tomorrow based on how it has been previously and how it is today. We do this through modeling, as she may have told you, which basically, these are mathematical models that try to replicate or to simulate the processes in the atmosphere. But you can never come up with a replica of the atmosphere, because the atmosphere is a complex system with innumerable processes.
For specific counties, various models under the WMO are used to collect data in specific areas, and forecasters then meet to curate the specific conditions experienced in different areas.
If your county is prone to floods, for example, like Tana River, this information would translate to something else for them as compared to when your county is not prone to floods. Maybe your issue is displacement of people and there's flash floods. Another counties, probably there'll be people who are not able to move from one point to another, like Nairobi. When you have the flash floods, you cannot move from one point to another. So they will curate this area-specific advisories after we give the rainfall advisory. And then again, we also have the different sectors of the government that are normally listed within the advisories, and so they will also activate their different plans according to what the forecast is saying.
Through global coordination, Kenya Met can efficiently conduct accurate weather readings and hold informed meteorological consultancy to protect critical sectors in the nation.
weather knows no boundary, because whatever happens in one administrative unit, could it be a county, could it be a country, it could also affect what happens in a neighboring county or country. So for us to be able to forecast weather, we need information and data from other Met services which fall under different countries.
An increase in demand for forecast services has been on the rise since Kenyans have understood the importance of integrating weather patterns into their day-to-day lives. The department has prioritized inclusivity to even include Braille versions of weather forecast readings alongside sensitizing locals in remote areas.
County director of meteorology in all the counties works hand in hand with the communities. You'll find them even in barazas, where they are able to disseminate this information and they tailor this information to the county-specific need. So what the county directors initially do is identify what are the main activities in the respective counties so that the information they give is relevant.
The department has maintained that ignorance of the climate will only result in detrimental crisis that cripples advancement and societal growth.
It's very critical to factor in climate. And again, what we are advocating is a shift in our mindset, because we are a people who are used to responding to crisis. But what we are advocating as a department is from crisis response to climate preparedness. Because when you're prepared, you're able to plan better. So for me, we can't afford to ignore the forecasts.